There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is Spencer Schneidenbach, a software consultant and AI architect who spends his time helping organizations move AI from demo-worthy experiments to real-world production systems. In this episode, Spencer and I have a conversation about what actually works when you start developing AI smart features for your software apps, and what parts of the current AI hype cycle tend to fall apart in the real world. If you're trying to figure out what the development of practical, production-ready AI features actually looks like for your software teams today, you won't want to miss my conversation with Spencer. Welcome, Spencer. It's great to finally have you on the podcast.
Great to be here, Jay. How are you doing?
Doing really well, thank you. And you?
I'm doing also really great. Excited to be here.
Right.
Excited to talk AI.
Yeah, I know. It's obviously a big thing going on right now. And I know both of us are thinking about and talking about this a lot at the different events that we often see each other at.
100%.
So I'm excited to talk about this with you in a recorded conversation instead of just informally.
Yeah,
like
share it all with the greater world. It's exciting.
Right. So one of the things that you and I talk about a lot is what you might call AI assisted development when we're hanging out together. But there's this other side of AI that's definitely impacting what we do as custom software developers, which is what I call AI smart features as a way to just kind of differentiate it from some of the other AI topics. What terminology do you like to use for that? These things are still evolving. And then kind of how do you define that? Jay here. Just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation.
Yeah, so I typically refer to the one side of just like Claude Code, Codex, or Cursor, whatever you use as agentic coding tools. The other one, AI smart features. I usually just integrating AI with applications. I haven't figured out a fancier word for it yet. But what was your second question? I'm sorry. It was
how do you define it? Like,
how do you
when
define
you think about these AI features?
So it's typically like how I typically look at AI engineering from, and I'm just going to put my cards on the table and say, good AI engineering is the first and foremost thing that the audience needs to know that people don't realize or people don't really think about, is that good AI development is actually 90% good software engineering, and then just adding AI on top of that in a little bit here and there. So to that end, AI integration of AI features is really about like, how do you put a good feature that AI could be useful with, that AI could be used for into your applications in a value added way. And I think that it's really important that I focus at my consultancy on the value added side of that. Like if a customer comes to me and says, I want to add AI to your feature, I'm like, cool. Or I want to add AI to my app. What do you want to do? What do you want it to do? And why is it valuable? Those are the first questions.
So I'm assuming you get this as well. I get this at Trailhead sometimes, where basically someone has come to me and said, my executive or my board is saying we have to AI something. How, you don't want to say no to that, right? Like that's okay. That's the goal of the company right now. So how do you like, what are your follow-up questions then about how to make sure that you're not adding a useless AI or, yet another chatbot that pops up inside of a software application, but something truly useful for that client?
Typically, I will have a good sense, especially if I'm day to day with that client. I'll have a good sense of like our my consultancy tends to really be like, I tend to really hire and bias myself towards product minded engineers. And we have team leads that, manage the relationship with the client that are also really they're not just customer success people, they're customer success people, but they're also kind of fractional CTO types. So typically they'll already have some idea of, if it's an existing client, they'll have an idea of how or what their strategic priorities are. And if we can figure out a way in order to get that strategic priority solved, at least partially with AI, we'll do that. So most recently, I'll give you an example. One of my clients approached us, and again, the CIO of that company went to I'm sorry, tornado. There's tornado warnings going off. It's gonna another one. Yeah, I know. Another one's gonna happen here in a second. So I'm just gonna, before it goes, bzz, I don't think the tornadoes are near us, but all right. So let me give
that's
one.
Exciting.
Yeah, there it happened. I told you it was gonna happen. It happened like 3 times. So let me give you an example. So I had a CIO of a client of mine who went to an AI conference, got really excited about AI. And it's just in the way you described. The board says it, or the executive says it, or the owner says it. They want AI features enabled in their application. And so we knew that one of their strategic priorities was they wanted to reduce spend on support personnel. They said, we just want to, basically the quite honestly, the payroll for that is quite high, and we want to find a way to reduce it. So knowing that, we said, well, maybe AI can help with that, but there's actually a host of other things that we could do. Like, what is it that they're calling about support for? Why are they calling your support line to begin with? Is it because they're not able to take some kind of action inside the application and support's just acting as a simple gatekeeper? But on top of that, could we add in something that allows them to self-solve for these things, like some kind of chat agent or some kind of a chat agent or enhancements to the platform that allows us to get more directionally towards like the end goal? And I told them in this project, I said, we are going to keep the end goal in mind. If the end goal is that you want to reduce the amount of people that you have on your support staff, that's great. That's a great end goal, but we are not adding AI just for AI's sake. So that's typically, the answer to your question is it's all consultative at the end of the day. And if it's a new feature, if it's a new client and they say, we want to add AI, we start talking, well, what are your strategic priorities? Let's get to know you as a person. Let's go to dinner, go on a little date, get to know each other a little bit, schmooze. And then we can start talking about, well, how can AI actually help you?
Yeah. And then you, like me, I imagine, are listening for the things that they're talking about to see the ones that sound like they might be a good fit for AI. Is that right?
Yeah, but oftentimes, like if I heard 3 strategic priorities and the third one is by far the least important, and the first one can't use AI at all, or uses AI in a limited sense, I'm just gonna come out and say it. Like I have straight up told clients, like, I don't think that based on what I know about this, that AI, like, we can build it off onto the side, but the investment point for what you're trying to get us to do, if you're trying to open up a new revenue stream, and we don't think like AI assisted tooling, okay, maybe it's creating a new website. That's not what we're talking about. If we're talking about AI integrated into the application, then I might just say like, hey, maybe now's not the time. Maybe we look at it a couple of months from now, or maybe we run off and you get your engineers kind of into it by, you just want them to get used to it. Okay, go off and do a little experiment. But at the end of the day, I'm just not going to tell them that they're going to need AI if they don't need AI.
Yeah. Along those lines, I'm curious if you have any examples you can share of, a lot of times clients will come with a solution in mind already. Can you build me something that does X?
Yeah.
Have you had anything where clients come to you and said, I want you to build this with AI, and you've said, actually, that's not a good fit for AI, something you've had to talk them out of?
Not per se, but but it's not something that I've had to talk them out of. I usually just kind of work through, like, are there, like I said, for the support example, are there other challenges that are getting in the way that they feel like they have to call support? But everybody, they come to me and they want chatbots. At least that's like how it started. Because I think that when people think AI, they think about ChatGPT or Claude, and they're like, cool, well, that's my entry point into AI. So monkey see, monkey do. They come and say, well, maybe we need the same thing. Maybe we need the same entry point. So they come to us and they say, hey, can you help us build a chat agent? And I'm like, that's cool. But I had another client that came to me and said, we really want to build a chat agent. And that's where we want to start. And I said, cool, that's great. But then they started talking about other parts of their business and how important predictive analytics are to them and how they don't have a predictive analytics product. And I kept telling them like over and over, like, I can assist you with that.
Yeah.
That's not even strictly speaking an LLM product, but like if you're talking about building a nice big old moat around your application and making you as sticky as possible, then why wouldn't you go focus on this predictive analytics project and try to figure out a way to use machine learning in order to predict? It was, in this case, it was just like small pieces of equipment in a manufacturer. Like if you're trying to predict failures on that, that's way more important. They didn't ultimately bite on that. They convinced that they wanted a chat agent. So chat agent it was.
Well, along those lines, I think non-technical users, when they think AI right now, probably 90+% of them are basically thinking ChatGPT, because that's kind of the thing people know.
Yeah.
Which is obviously a chat agent that gives you access to an LLM to chat with. What are some examples off the top of your head of some non-chat based AI implementations that you think are, commonly useful?
I think my favorite one so far, I mean, agentic development, like I think it doesn't have to be complicated. So just little tiny specialized agents that maybe the chat agent can invoke, maybe it just sends an email. Those are my kind of favorite things. These like very specialized agents that just have a particular task or thing. And they're not really, you can interface with them with chat. Maybe it's a separate tool. And for your audience, if you're not familiar with what tools are, that's just something that you attach to the LLM that allows them to give them additional functionality like web search or maybe even querying your database, depending on the use case. My favorite one so far was we wanted to be able to evaluate, it was for a call center analytics company, and they wanted to be able to evaluate whether or not an agent that fielded a particular kind of phone call followed the correct procedure. So what we initially did was we set up a huge eval framework because, spoiler alert, when you get to the reliability part, I'm going to talk about evals. It's really important, okay? But we started by I'll give you the example that is just off the top of my head. It's like, did they follow proper HIPAA procedure if there was a HIPAA mismatch? So if they said their name, but they said the wrong date of birth, did the agent follow that procedure? And we found out very quickly a single LLM call just wouldn't cut it. Like it would not work. It had like a 50 to 60% reliability rate. So I built a small engine that basically allowed them to workflow and chain together calls to LLMs. Again, that basically broke that question down into multiple LLM invocations. This isn't groundbreaking. It's not crazy. It's not unpredictable. But what we did was we built an entire product, front end and back end, including built-in evals around this concept. And I was really proud of that product simply because like LLMs were like a very important piece of it, but they were like 5 to 10% of what we actually did. What we actually did was productize and build a system around that workflow engine to make it useful and to make it easy to build these, what they ended up calling models, which I think were kind of a silly name because model is such a broad word. But
Right.
these individual, you could think of them as like skills to evaluate that customer service call. So that was probably my favorite one. That was nothing to do with a chat interface.
Yeah. And so is that based on like a transcript of the
Yes,
conversation?
exactly. Yeah. So they've been analyzing and getting, building analytics out of transcripts for years. So take an audio file, break it down into the transcript, and then just answer a bunch of questions about it. And this is, if you couldn't guess, with the mention of HIPAA, it's a little bit in the healthcare space. So we have a bunch of custom healthcare related analytics models that are actually just based on base neural networks. And the problem with building more of those is that the time to market for those neural networks, in order to get to market, they are actually way cheaper to run, but they take months more time to actually build and deploy. So that was why LLMs were such a good fit, because it took greatly shortened the time. We didn't need to build a custom neural network. And now we have all this data that we can use to build, distilled models if we wanted to, and even reduce the price even further. So
that's interesting. We had a client who came to us a little while ago, almost a year ago now, when LLMs were still a little new, and they were like, "Hey, we've got all this data, we want to use it to make some predictions about our customers." And we looked at their data, and it was a real mess. It was all over the place. It was inconsistent. And we said, well, okay, step one is to like clean all this up so that we're not training it on bad data. But they were like, okay, well then, is there something else we can do in the meantime to get AI into this? We ended up just using an LLM, even though they probably have a gold mine of specialized data that they, if they cleaned it up, could actually train this, a custom machine learning model to make some really unique decisions. But the LLM worked great. It's kind of amazing what they can do.
It is, but it's amazing what they can do and what they continue to be able to do, but they still fall over themselves all the time.
Yes.
And there's no, so what you're describing is kind of a, like, I think that there's this thing in the market, that this belief in the market by not techie, that are like, LLMs are, so amazing. They can pretty much do anything. It's just so turnkey. Like that you could throw any problem at them and they could solve it. Even though hallucinations are greatly reduced from, 2 years ago when we had the GPT-4o models. The models got so much better when they could think and use tools during the thinking process. I think the big unlock personally was GPT's o3 model. I thought it was a fabulous model. And I think that was probably the biggest in terms of pure LLM usefulness, was like the biggest leap was o3, like the introduction of o3. But even then, they still hallucinate. They still have problems. And if you're talking about something that's business critical, you may find that even if an LLM is 90% accurate in one shot, the difference between that 90% to 99% may be deal breaking. And I'll give you another example from the healthcare industry: adverse event detection. You're talking about things that compliance events where somebody experiences symptom of during in the process of taking some kind of treatment, that they then have to turn around and report to the FDA. No healthcare company on earth is going to want to hear, well, we're 90%. No, they want they want that certainty to be way, way up there.
Yeah, you don't want 90% of your airplanes to land without incident.
Exactly. That's a great way of putting it. Yeah. Oh, sorry. Next time, we'll reassemble the aircraft. And next time, you're absolutely right.
Okay, so we talked about LLMs quite a bit here, but there's all kinds of things that machine learning models can do besides chatbots. I think a common one that people don't think about, non-technical people don't think about, is classification. Have you had any good opportunities to use machine learning models to do classification?
My machine learning journey really started at LLM. So I'm actually getting ready to work on a project that will kind of take me backwards into more of the machine learning data. I do have a team that does it, but me personally, that is something like we've tried to sell it a couple of times, but at least when I started my machine learning journey, I didn't really have any machine learning, or it all started with LLM. So that's the tool that we use. But I do have clients that have machine learning teams, and they do train those neural networks. But even though then it's quickly becoming like, okay, we actually are able to get to market faster and better by curating a big data set, making it so that we can, making sure the data is really clean, and then using it to train custom LLMs. So, I've seen the conversation kind of move away from classic machine learning, but even though it absolutely still has a place.
Okay. Well, with going back to the chat interfaces a little bit, have you, I know we're both coming from a .NET background, so I'm curious if you've had a chance to use semantic kernel to build anything.
Yes, semantic kernel was a major piece of the first LLM project that I got. So 2 years ago, actually about 2.5 years ago, starry-eyed me, busy in .NET, still Claude Code wasn't a thing yet. My manager came to me, one of my managers, one of my clients came to me and he said, "Hey, you're going to be our generative AI lead." Okay. I don't have any machine learning or data science background. You made the right choice. This is going to be great. And he said, no, it's going to be great. First thing I need you to do is go find out, is Microsoft actually going to support semantic kernel? I was like, what the hell is semantic kernel? What even is that name? By the way, still one of the worst named Microsoft products, and they've got some doozies. But yeah, the entire foundation of the project that I took on, which was a chat agent, by the way, was built on top of semantic kernel. But as is the way it goes, semantic kernel kind of, they announced, yeah, it's a mature product, it's in maintenance mode. So now, of course, they've moved on to Agent Framework, which is, I think, a better series of abstractions for AI agents personally. So the
Yeah.
answer, in short, is yes. That's where I started my journey, is having to figure out semantic kernel and all the things around it.
Yeah. So when it comes to things like that, semantic kernel or the modern version of that has kind of been rolled into Agent Framework, but there's part of Agent Framework that's basically meant to build chat interfaces.
Mm-hmm.
Could you describe at kind of a high level to somebody who was just getting started with it? How would they know if that set of tools is the one that they need?
I think the answer to that question really comes down to, like right now you have LLMs that are built in with a spectacular amount of functionality out of the box. So
Mm-hmm.
if you're focused on building something with Chat GPT, 5.5 is the latest model. If you wanted to build something with that and you wanted to leverage, you were like wanting to ask questions that leveraged the web search tool, for instance. It's very easy. It's just a few lines of code to do that, to get the web search tool, and then to have it invoke, ask a question. LLM knows the web search tool is there. It can use that. But how is that useful if you're talking about, you want a chat agent that talks to your data or speaks the language that you have? You can only get so far with prompting. So semantic kernel or agent framework really start to shine when you're like, okay, I have a custom .NET application or Python, and there's tons of other frameworks, right? Like the Vercel AI framework for TypeScript. At this point, every platform, every ecosystem has their flavor of this. And Python, that's a few too many, in my opinion. But you come in and you're like, okay, I want this person who's logged in to be able to answer questions about their particular application. So you would reach for one of those frameworks to build what are called tools to actually go and give the LLM to say, hey, if you need to know, something about the customer's inventory for a particular item, here's the tool that you could use to do that. And that tool would basically wrap some kind of SQL query that would go into the database and maybe provide some additional context back to the LLM in order to interpret the database result. But that's when you start to like want to be able to read data or even make mutations inside of your custom applications. That's when you would start to reach for those tools.
That's a great explanation. One of the problems, I think, maybe you agree with this, that exists right now is AI stuff is developing so fast. There's like a bunch of different ways to accomplish the same thing.
Mm-hmm.
What you just described, I feel like also describes essentially setting up MCP tools that you give your LLM access to. So if I was getting started on a new project where I knew I needed to give an LLM access to data in different systems, how would you decide between those different approaches? Am I writing a custom MCP server or set of servers, or am I using semantic kernel / agent framework to do that?
About a year and a half ago, I remember Twitter blew up. What did they call it now? Y, Z, or no, X? That's the one. Twitter blew up about MCP. They were like, this is the greatest thing ever. And I was staring blankly at it like, I don't get it. What is this? It's remote procedure. It's remote procedure calls for tools. What am I missing? The first thing is the step 0, Jay, is really to understand LLM fundamentals. This is a struggle I've had with my clients and my employees, is that I have great software engineers, right? We have this great team of people, and they just want to look at the code and they just want to go. And I say, no, you got to stop and understand LLMs at their fundamental level, right? So, and I'm getting to the answer to your question. First thing I would do is skip MCP, like until you actually need it. MCP is a useful thing if you have a series of tools that multiple LLMs inside of your organization, multiple agents may need access to. But if they're operating in the same memory space, depending on what you're doing, you're probably better off just exposing it as a tool call, because MCP servers have a cost. And this is where I say LLM fundamentals are really important. Because when you add an MCP server, you are adding basically a description and a schema for every single one of the tools that you have available. And if you have an MCP server with 10 tools, you are already stretching the limit of what an LLM, like you are adding so much to the context window. And for those who don't know, the context window is a maximum set of tokens. Those are the underlying primitive that LLMs use to read data, right? when you have a context window that's 1 million tokens and you put in 250,000 of them of just MCP servers, you have already preloaded the context with so much stuff that you are actually degrading the performance of your LLM. So my suggestion would be skip MCP and just start by doing like some simple database queries. Go into Agent Framework, add in a couple of tools. It's really only a few lines of code to do that do some queries and answer some basic questions. And go from there. You may evolve to using MCP servers, or you may have something like Jira or Figma or something where you're like, I'm an external service and I want to externalize some of this stuff. So create an MCP server to like look at all, look up Jira tickets or, Figma designs, things that exist today. But if you're starting internally, starting quietly, like you do not need to reach for MCP right away. It's almost it's important to understand it as a construct for something that you need to know. But it's not in and of itself very useful until you get to a use case where actually writing an MCP server makes sense.
I think what you said right at the beginning of that makes a lot of sense to clear it up, which is if you have multiple things that are going to need to call the same tool. I mean, that's essentially like creating a REST API, right? If you have multiple front ends that are going to need to call it, if it's only going to be one application, you're creating overhead to have an API with HTTP communication back and forth. If you could just have it be a function that you call inside of a library in your application, right? Like that's going to be a lot faster in process and whatnot.
Yeah, 100%. I think that MCP is in a layer of complication that if you need it, you figure it out and you need it. But like I see some AI engineers who are like, I just want to make sure that I do and understand all the things. And so they want to make MCP servers. And I'm like, it's not the place to start.
Yeah. So if you're building a custom LLM tool of some kind that needs to have access to tools or resources within your organization, MCP is an option, but it's an option that is going to add some overhead, and you got to know what the trade-offs are, like any good engineering decision.
100%.
Okay. Yeah, that's a great summary of that. I appreciate that. Another area I think that is commonly overlooked as an AI smart feature is this like vector embedding cornerstone technology that a lot of LLMs are built on top of, that you can use to do things like vector search, RAG, retrieval augmented generation. Have you had a chance to do any implementations like that?
Tons. RAG is a big part of my world. And the thing about RAG is it is a beast unto itself. I think that the thing that I think people, when they start to get into LLMs, I think that when you look at vectors, and vectors and embeddings specifically, it really is just another tool in your toolbox. But by and large, like that doesn't mean that it's an appropriate tool for every application. And what I see as engineers are like, well, we don't have to do, BM25 search, but in reality, lots of different search techniques that have existed BM25 is the core that runs many retrieval systems. Okay. And it's existed for the algorithm has existed for 50 years and nobody's been able to find something better than that. So, vectors and embeddings are one of those things where it's like they are useful to add to a search system. They're good at picking up like context around specific phrases, right? Like if you're searching for two things that are similar that don't have necessarily or full text search where you're like, oh, it's word for word, you're searching for this thing, but you're not going to find it because of the context, because it's more of a contextual search. That's where embeddings and vector search comes in. But I have found by and large that it is a combination of existing search techniques in addition to RAG. And even then, Boris Cherny of Claude Code has said that we tried doing basically some people just want to overcomplicate it. You may not even need it. You may just give a specialized agent a series of search tools and say, hey, here's a general problem. Here's what the users asked for. Go see if you could use your tools to find that thing. The agentic search, where you give an LLM a set of tools and a prompt to go find things, was proven internally at Anthropic to be more effective than trying to vectorize or trying to do
Hmm.
searches across your code base.
Hmm.
So RAG is a complicated thing. It's very nuanced, gets very nuanced very fast.
So other than, like a SharePoint repository of documents that you're searching with RAG or something kind of, I don't know, vanilla like that, have you had a chance to integrate vector embeddings and use it for search in an application that you could talk about?
Yeah, for sure. Well, so yeah, we had a particular thing. We had a particular um, a particular client where they wanted to be able to search for documents across many different and each of them was just like put on you could call it just like just a regular drive letter. They called it their E drive. Okay. And
Okay.
the E drive was literally an E drive on a server, like literally Windows. You go to C drive, you went to E drive for all these documents, and all those documents went into different folders. So yeah, we had to design an entire synchronization and ingestion process that was specific to this because of the nature of the business that they were in. It had to be specific to them. So and because it was all on a server, we were like, well, we're just going to find a way to create basically create the synchronization agent that sent these documents up to a central server where they are then in turn converted into embeddings and then stored inside of a database. And that's where we found out very quickly that, well, I mean, we didn't find out very quickly. We knew this up front, that they had file formats of all different kinds. They needed to be able to handle them all. And Excel in particular was an interesting one because you have to, the Excel document itself may contain a lot of numbers or a lot of information that is you can't just straight embed that if it's just embedding a table of data. What we ended up doing was creating an ingestion process that specifically for Excel spreadsheets, we would go in, we would figure out the purpose of the Excel document. We'd embed that purpose that we generated, and then we'd store it inside of our database. So that way our search system on the other end could better find that information.
Mm-hmm.
But yeah, I've done that. I mean, at this point, vector search, and really most of the time we reach for hybrid, right? Full text combined with embedded search, and then we tune from there. And that
Yeah.
seems to be, but yeah, we've delivered on those a lot. A lot of them pretty straightforward, but some of them not so straightforward. And that's where you really have to come in and really stretch your engineering knowledge.
Yeah, a lot of people, I guess, forget to think about the different file formats. So if you're just getting text files sent to your system, that's a very simplistic scenario. Once you start adding spreadsheets and Word documents and PDFs and images, right? Like all of those are going to be serialized into something useful to an LLM in a totally different way from the others.
And I think that the main thing that I have with LLMs, if I summarize down to the one thing that I'm asked to do by clients, it's how do I make this thing that is by its very nature non-deterministic? How do I make it as deterministic as possible? So there's nuance because you can try to embed all these documents, but on the other end, if you're embedding stuff that's not relevant anymore, because it was very common for in this particular case to have 5 spreadsheets that are all copy and pasted, but only the last one that was edited was actually the useful one. So we had to design that into our ingestion system to basically say, if this file already exists, we need to get the latest version of it. And if it already exists and it just has copy 1 in the name or something, so it just gets so crazy nuanced so quickly, because what if we had not done that, what we'd ended up with is just a bunch of garbage. And you know what they say in engineering, Jay? Garbage in, garbage out. And that's never been more true than for LLMs. So I have done everything that I can to try in these projects to try to minimize the amount of garbage I send to our core systems, because at the end of the day, LLMs get lost really, really quickly.
Well, I'm curious along those lines about testing when it comes to these systems, because I mean, by their nature, these systems are non-deterministic. You could ask them the exact same question or give them the same search or prompt or whatever 2 times in a row and get a different response. So how do you go about testing these kind of non-deterministic things?
Well, I think that the first thing that I do is, and I know that when you had Corey House in an earlier episode, he already kind of gave my thing. So if you're working with a non-thinking model, you can adjust the temperature down to get it to be more deterministic, right? And I know it was me, and then I stole it from somebody else when he said that LLM, like that the temperature is like the blood alcohol level of the LLM. The higher it is, the more creative it is, but the less deterministic it is. And by the way, a zero temperature is not a guarantee of determinism. And the reason is because there's a lot of physical things that we can't control, like even just the hardware that the LLMs run on can ultimately fire off different neurons to elicit a different response, even at a zero temperature. So all of that to say, the main thing that I do is evals. This is the focus of most of my implementation and research. The biggest problem, the biggest, like, a lot of our job, Jay, is managing expectations with clients, right? Like that we both own software consultancies. That is like the thing. And when somebody comes to me with an AI project up front and doesn't cannot clearly articulate, when we say this, ideally the LLM does this, then that usually is a risk point. And it's usually like, but that's what I want to know up front is like, what do you want it to do? And then what I can do is I can design a series of tests that I can run anytime. And basically from the output of those tests, I can say that, did adding this tool fundamentally change the response? Did adding this thing to the system prompt make it work better? So when I did this first project, I knew that evals were probably the most important part of the whole system. In my opinion, there's your LLM system. If it's not backed by evals, it's not backed by anything, because you cannot operate with faith that it'll work well. So what I did is I have a chat agent and it has 400 plus unit tests. And it's also written in C#. It's not hard stuff, but I run those tests. And if I make a change to the system prompt, or I make some kind of fundamental behavior to how the LLM receives tools, I can run that series of tests. And as long as the threshold we establish is as 90% of them are passing and there's no major grouped regressions, like one tool doesn't get called anymore, then it's good to go. We can't go for 100%, but we go for pretty dang close. What we're looking for is major regressions. And if you're not measuring that as you're building your AI system, you really are doing it wrong.
Yeah, that's interesting. When it comes to unit tests, I think we're not used to thinking about it from anything except 100% level.
Exactly.
But with a non-deterministic system, you have to apply different standards.
100%. And so that's another shift. Like a lot of the struggle that I see engineers, classic software engineers, is just like this idea, really grasping this idea of non-determinism. But when you're working in an LLM, if you have an LLM system, you cannot guarantee its output. You can get pretty darn close, but even a fully evaled system will occasionally, like I said, it could be running on different hardware. It could be a solar flare. It could be literally anything. It could be Jesus decided to flip a switch one day and say, this LLM's going down this neuron set. You just can't add determinism, but you can get really close as long as you're really disciplined about it.
Yeah. One of the other things that is hard to keep under control, I think, when you start using LLMs and a lot of other cloud-based services as well, is cost. And so I think you've got a talk that you've done before where you talk about a system you deployed and then later were able to reduce the cost pretty significantly. What kind of tips and tricks are the current state of the art on how to save money when you're doing this stuff?
Well, in that particular talk has an interesting, it had an interesting thing about it. Like this was back early on when I was still going with LLMs, and I was just like, and you want to bring the conversation back to semantic kernel. I think one thing that semantic kernel did was really encourage bad habits. And so what I would do is, as I was building the chat agent on the system and answering different questions, having it answer different questions, I would go in and say, okay, well, they want to ask this question. They want to answer to this question. So I'll add a tool to add that. And I just kept adding tools. And then I found, because I was measuring the whole time, that all of a sudden I saw regressions. I was adding more tools, but the LLM wasn't able to keep up. And so what I ended up doing was basically creating a semantic search system for my tool. So you talk about RAGs, very meta use of RAG, but I would RAG over based on the user's last 10 requests. I would say, give me the most likely tools in this scenario, like the ones that you think would answer the question. And it was a very simple invocation that happened before the user's response. And I would only send that subset of tools to the LLM. And it was like 10, because you start to see LLMs really degrade from a efficacy point of view in an agentic system when you start adding more than 10 tools. That's where the significance for latest models drops off. So we had basically an embedded search system for that. Another great technique is to take a bunch of data, like take a bunch of inputs, and then use a better model to answer that question. And if it answers it really well, you can take that data set that's generated and create what's called a distilled model. So you can take a more expensive model and use it to train a cheaper model. And you'll often find that the cheaper model with that training is able to beat or outperform the larger model without that training at a fraction of the cost. And I always start with as cheap a model as I think I can get away with, because ultimately, like, people just want to throw the most powerful models at it. But dude, God, LLMs are expensive. Okay, they're expensive to run in production. So I try with the cheapest model. In fact, the aforementioned workflow project that I did, I really wanted to make it work on, at the time, GPT-4o Mini, and I worked really hard in order to make that happen. And when I was able to tell the CEO, by the way, you want to sell this thing, but I'm able to do it because of this research that I did ahead of this. We're able to now execute at scale at 1/10 of a cost. Let me ask you something, Jay. If you're the CEO, are you happy with a statement like that?
Yes.
So those are use cheaper models, use distillation, and get creative with how you send tools to LLMs.
So many and I'm not speaking about developers here, not including myself. I think all developers, including me, now we're used to having very complex languages and frameworks that do things for us and be able to use as much memory as you want. And it's easy to start using LLMs the same way, where you just say, well, I'll just send everything down to the LLM again.
Exactly.
But the context costs, right? All those tokens cost you. So
and
being careful matters.
It does, and you let efficacy slip as well. It's way more important not to use a more powerful model. It's way more important to be disciplined about how you're building your AI feature. So building with lots of testing and measuring up front, like putting that investment in.
So you were talking about being efficient with cloud-based models, but what about local models?
Local models are so I don't have I have a bunch of GPUs here. Like I was telling somebody earlier, I've got like a 5090, a 4090. I've got another computer upstairs that has a 5080 in it. So I could make a nice little like local LLM thing. But what I've been using is my MacBook Pro, because I did buy it when I bought the M4 Max. I bought it with as much memory as I could get. At the time, it was 128 gigabytes. So a nice, really beefy machine, really nice machine. I have used local models. I'm really testing the agentic coding models more than I am testing any other model. And the reason is that I think that the foundation models are really good, and you can optimize. I feel like trying to pick something off of Hugging Face and then like trying to optimize it for a specific problem, that's a good problem if you know that you want to train an LLM and you know that you want to like ultimately come up with that. But when I tried, for example, using a local model to just even evaluate the workflow system I was doing, it just wouldn't run fast enough at the time. And my computer started turning red. Like all of a sudden I saw smoke, and I was like, not really though, but like it just wasn't fast enough. So my local LLM story, like I have used open LLMs, but it's mostly like just been here and there. I found for the work that I do, people just want to stick with, like, they're fine sticking with foundation models. There is a time and a place though for local models. I think that the future's in local models. That's the one, your takeaway. It's like, we are going to, the gravy train of essentially unlimited tokens will end. But the models are getting better and they're getting smaller too. So the local LLM story is going to is important today, and it's going to become very relevant even to the mainstream.
It's crazy that right now you can get like the tokens and the compute and everything for less than it would cost for you to do it yourself. But you got to believe that someday they're going to flip flop, and you're going to be able to run a local model that's very efficient, purpose built, on your own compute and
I
have it
think
be cheaper than these general purpose massive models.
Well, I think their bet is that they'll be able to do more with less one day. And I think that bet is currently paying off. I think that we are going to, if we haven't already, I think we're going to fundamentally reach the limitations of LLMs. And then the question is like, what's the next technology? The one thing that they can do, they are really trying to stretch this architecture as far as it'll go. And things like the mixture of experts model. You have an LLM that has a ton of tinier, smaller LLMs that reduce the amount of VRAM that it takes in order to run that model. I think that's important research. And I think that those kinds of innovations are going to continue. And they'll just, it may very well be that in 5 years, they're able to run these things very, very cheaply, like Anthropic or OpenAI, that they're able to run them very cheaply with less compute and be able to continue to sell essentially unlimited tokens. We'll see. I could be wrong. I could be wrong.
Yeah. It's an interesting debate because, I mean, it reminds me of processors, right? And Moore's Law, where
yes, it's exactly
for how long
the right
have people
analog.
been saying, well, Moore's Law is dead. And then they figure some little trick out. Yeah, they can't keep making the, number of nanometers smaller. At some point, there's a single atom wide,
Yes.
and you can't get any smaller than that.
Right.
At least not that we know of. But they keep figuring stuff out, and
Yep.
it keeps moving. So
that's exactly correct. I think of the Moore's Law is what I think of too. So I talked to a Microsoft engineer last year who said that the models are getting 1 standard deviation cheaper every year, but 7 standard deviations smarter. I don't know that that was maintained from that year to today, but like that is what you'll continue to see is the cost getting driven down.
If that continues, it's great. When it gets to be 1-to-1 or worse, then it's problematic.
Yep.
Well, you brought up something that I wanted to ask about, which is multi-agent flows or multi-agent work. Have you had a chance to do that? And if so, can you talk about what you did?
Sure. I mean, the aforementioned workflow project is probably the one that it was like, okay, it's basically just a small system, but deterministic in that it is choosing to, based on the output of one LLM, to invoke another LLM. So that is kind of agentic-esque. And I'm going to say my spicy opinion, which is that my spicy opinion is that workflows trump agentic programming every time. So if you have a defined way that you want to invoke LLMs, then just run it. Just define it and then run it that way. On the other hand, though, there's been plenty of times where it's like, yeah, I want to defer to a smaller agent. And there's a bunch of different levers that you can pull in that regard. The simplest one to me is just like an LLM that has a tool that may invoke another LLM. That is technically agentic programming, but it's also very useful. And it's nice to break things down like that because you can, guess what? Go back to the evals. You can eval one separate from the other. So those are the kinds of things that those are the kinds of things that I've done. I've really tried to focus on just like keeping my agentic flows pretty shallow, so to speak. It makes the system easier to manage, to understand, and to evaluate for.
Yeah, that's a good advice. We could talk about this forever. I feel like we got to land the plane at some point before it goes into the multi-hour.
I haven't figured out a place to land the plane yet. That's some good questions.
Yeah, these are a really interesting topic. So maybe we'll have to have you back to talk about the new state of the art, 2 months from now when it's all changed. But let me land the plane with this last question, which is something we like to ask all our guests. So the theme of this podcast is making software projects more predictably successful. As you know, software projects are notoriously difficult, and using AI to build them non-deterministically hasn't made it necessarily more predictable. So what other topics, or what other guests do you think would be good to have on the podcast?
I think I'm going to answer with 2 different names. I think one, if you wanted to talk more about AI and more importantly, like the fundamentals of AI, like machine learning, I think Matthew Renzi, if you haven't spoken to him already, is probably one of the smartest researchers in that way, and has in talking about machine learning and AI and how we're directionally going. I'm a little bit close to the metal because I'm working on client projects. I don't know that Matthew still works on consulting projects, but he'd be a good person to ask about, like, how do you make AI or machine learning more predictable? It's probably going to sound very similar to me on the eval side. On the other hand, somebody else you should talk to, our friend Scott Sauber. I mean, Scott runs a much larger organization than I have, and I think you have. And so like software predictability and like project predictability is pretty much his only job at the end of the day, if you could put it down to one thing. So
Mhm.
he would be a good person to talk to. I find myself like the more like in terms of software though, it's kind of funny. I find myself like reaching for agentic programming so much. It's like, what, like, do you want to talk to a language designer? Do you want to talk to like, I don't know, but if the LLMs are producing all this great code for us, I'm like, what is the place for all these things? So those are the two names I would float. Those are the two names. No specific subjects though.
That's great. Well, both mutual friends of both of ours. So I
Yeah,
think
that makes it
I,
easy.
I think that's a pretty easy win for the podcast there, and good suggestions. This has been a really interesting topic, and really appreciate your expertise on all of this, Spencer. So thanks for sharing your time with me
Glad to
today.
be here. Yeah, thanks for having me.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.